This is lesson 3.3, order of operations with exponents. So we've already talked about order of operations this year. We know how to use BEDMAS and what it stands for. We use BEDMAS to determine the order of operations when we're simplifying expressions. And now we're just going to use BEDMAS when we're working with powers. A new thing that we don't know yet is a coefficient. Coefficient is the number in front of a power, or sometimes you might see it in front of a variable. And you just treat a coefficient like multiplication. A coefficient represents how many of those powers exist, or how many of the thing that it's in front of, how many of those exist. So for example, 2, and then in brackets, 3 to the power of 4. 2 here is the coefficient. And then the 3 to the 4 is, of course, the power that we've been working with already. This is equal to 3 over 4 plus 3 over 4. But it's just easier to write it as 2 and then like 2 in front of it because there's 2 of them. So why write them out? Like why repeat the same thing twice? You can just put the coefficient out front. And you can see how it gets a lot simpler if you have a ton of them listed. Like let's say you have 10 of these listed. It's way easier to write 10 and then whatever the power is instead of writing them all out. So how do we simplify when we have a coefficient and a power? This example here, the first number out front, the 4 is the coefficient, and then in brackets, that's the power. We don't have a multiplication symbol written here, but we imagine that it does exist there. Because when there's that bracket, it means these two things are being multiplied together. There's 4 of these 2 to the power of 3s. We simplify by first calculating the power, or doing what's in brackets first. 2 to the 3 becomes 8. And then the second step is we just multiply that by the coefficient. Because once we have, like 2 over 3 becomes 8, and then you're just left with 4 bracket 8. And remember, when there's no operation written there, the brackets mean that they're being multiplied together. So we just multiply them together and we get 32. A couple more examples. So we've got 6 to the 4 plus 6 to the 4. A simpler way to write this is using our coefficient. There's 2 of them in total, so we can just write it as 2 times 6 to the power of 4, because there's 2 of them. Then to simplify, first we work with the power. We have a repeated multiplication. It's being repeated 4 times. We do our long multiplication to figure out that this is the value, 1296. And then the very last step is we multiply it by 2, or whatever that coefficient out front is. And then we get our final answer. For the second example over here, we already have it written with the coefficient. So we just have to simplify. Again, do the brackets first, do the power first. This is 5 times 5 becomes 25, and then we multiply the coefficient by that reduced power to get 75. For this example here, we now have 3 of them listed. 2 over 3 plus 2 over 3 plus 2 over 3. How many do we have? 3 of them total. We can just put that out as a coefficient because this step is way simpler than the original form here. Then when we're simplifying, 2 to the power of 3, there's a repeated multiplication, it becomes 8, and then our last step, we just multiply them together. For this example, we're given, like it's not written in our normal coefficient form, we do have the multiplication symbol here, 5 times 2 to the 4. That can be written like this because we don't actually need that multiplication symbol there, we can just put the power in brackets. And then we solve like normal, repeated multiplication, and then do our final multiplication at the end. We're coming back to looking at our negative powers. We want to identify the coefficient for negative 3 to the power of 2 in brackets, and then negative 3 to the power of 2 when there's no brackets. So for this one, the coefficient is just 1. It doesn't exist there. We don't see it. Sorry, it does exist, but it's not written because it's unnecessary and redundant to just write a 1 in front of this. We don't include it there, but technically the coefficient is 1. It just doesn't change anything because when you multiply by 1, nothing changes. So for this example, the coefficient is negative 1. We assume that there is just a 1 here. But again, we don't have to write out the physical number 1 because it's redundant, but we do need to write out the negative. Oops. And so we already learned in previous lessons that the difference between these is that here, the base is positive 3 because the exponent is not affecting the negative. And here, the base is negative 3 because it's in brackets, so the exponent is affecting all of it. So now we just have a name for what's happening with this negative. That is our coefficient out front. For this example, we want to write each expression using a coefficient and a power. So obviously how this is currently written out is a very inefficient way, and it's kind of hard to read. So let's write it in an easier way. The number that's being repeated over and over is 5. It's being repeated 5 times. So that's our base and our exponent. The number out front is the coefficient because there's 4 of these going on. So this just becomes 4 and then times 5 to the power of 5. This is a lot simpler and easier to read than the original form. In the second example here, same thing, the coefficient is out front, it's the -1, and then 7 is being repeated 3 times. So this is how we can write it in a simpler way. Again, we don't write the 1 there because it's redundant, but we just have the negative sign out front. Last example, we want to solve this expression using BEDMAS. Are there any brackets to start? Technically, there are sets of brackets, but there's no expressions going on inside of them that could use simplifying. They're as simplified as can be. There's no brackets, we move on to exponents. We've got 3 sets of exponents here. So I simplified all of them in the same step because we know that exponents are the next thing to do. And I showed over here how I knew what the answers were. So 3 to the 2 is 9, -6 to the 2 is 36. Remember, it's going to be positive because we have a double negative. And then 5 to the 3 is 125. So I've simplified each of those exponents in this second line here. There's no more exponents to do, but there is some multiplication. We have multiplication here and here. Because again, we don't have the x of the multiplication written out, but because the brackets are there, it's counting as multiplication. That is multiplication. So I showed a little bit of work over here. 36 times 4 gives us 144. And then 2 by 125 gives us 250. So I've gotten rid of multiplication. No division, so the only thing left is addition and subtraction, and we'll just do that in the order that it appears. So 36 minus 9, that gives us 27. And then 27 plus 144, that gives us 171. Lastly, we subtract 250 from it to get our final answer of -79. So that's how we can use BEDMAS and coefficients to simplify expressions with powers.